Okay, today we are going over solving polynomials by factoring. So 5.7 actually is probably the shortest of all the sections that are going to be on this test. But to solve polynomials by factoring, you have to be able to factor. So if you haven't gone through the homework from 5.4, 5, and 6, this section is going to be, or you're going to feel a little lost in this section because the solving part is actually the easy part. You'll see once we get there, the solving is just like a two-step thing that doesn't take that long. The biggest part in this section, the part that's going to take the longest, is the factoring. So what's nice about this section is it turns into a review for factoring, okay? Because the first step, once we see some examples here, you'll see the first step is actually solving by is actually factoring polynomials or trinomials. So once we get going here, you'll see first step will be just factoring, and then the second step will actually be the solving. So I'm going to start with the solving part because what we use to solve these polynomials is actually called the zero factor property. Let me write this down. Zero factor property. Okay, the zero factor property, we're going to talk about this for just a few seconds. And it says, look, if you know that two or more things are being multiplied and they equal zero, at least one of those things has to be zero. So if we had, for us, it's typically going to be two. But if we had like two terms being multiplied together, let's say just A and B. If A times B equals zero, then we know that A equals zero and or B equals zero. Okay, that's what the zero factor property says. And we're going to use it to solving by factoring, okay, to solve by factoring. Because what we're going to do is actually create multiplication. Remember, the last two sections we've talked about, we're going from addition or subtraction into creating multiplication, typically of binomials. But once we create the multiplication and we have it equal to zero, we can set both of those equal to zero, and then we'll just solve it out, okay? So the goal here really is to get one side equal to zero, because you cannot do the zero factor property unless one side is equal to zero. And then you factor the non-zero side and then just set each factor equal to zero and solve. The solving really isn't that hard. It's going to be the factoring, okay? The factoring part, especially if you have not done the homework over the last few sections. Okay, so and really the main difference in this section is we're going to have equations, right? We're going to have equal signs. Every section before this started, or did not start with an equal sign. It was an expression, right? An expression doesn't have an equal sign, and an equation does. So we're going to start with the equations here, and I mean, really straightforward. So let's look at a basic example first, where it's kind of set up to use this property. Let's say I'm going to do multiple factors. Let's say I've got 2x, and then we've already factored it. Let's say like x minus 3, and then x, let's say 2x plus 1 equals 0. Okay, so now this example has already been factored, but notice we've got an equals 0, so we can use the zero factor property. And we actually have three factors going on. We have the 2x, we've got the x minus 3, and we have the 2x plus 1, okay? Because all three of those multiply to equal 0, x could be something that creates 0 when you multiply, right? Like if that x was 0, 2 times 0 is 0, well, 0 times anything over here will make that 0. Well, like let's say this middle factor, if x was 3, we'd have 3 minus 3, that'd be 0. It wouldn't matter what the other two are. This whole side of the equation would still wind up equaling 0. So that's really kind of what we're finding. What makes 0 in each factor, so when you multiply them, it equals 0. So I'm going to set each one of these equal to 0. That's what the property says. And then I'm going to solve it out. Well, if 2x equals 0, divide by 2, we get x equals 0. So that's going to be one of our solutions. And these are solutions. I mean, we have an equation. We're finding solutions now. X minus 3, so I'm going to add 3 to both sides. I get x equals 3. We knew that one already, right? 3 minus 3 is 0. Now 2x plus 1, we're going to subtract 1, so we get 2x equals negative 1. And then we're going to divide by 2. So we wind up with x equals negative 1/2. Kind of neat, okay? And notice, look, we had 3 factors. We have 3 solutions. That's not a coincidence, okay? Not a coincidence at all. Okay. Questions? Kinley, are you good back there? If you're just watching, that's fine. I totally get it. No big deal. Let me solve this. Let me move this up a little bit. Okay. Okay, so let's look at another example where we actually have to use the zero factor property, okay? Well, I mean, I guess we used it there, but let's just start from beginning to end and use it. And look, this is going to just turn into a really review of 5.4, 5.5, and 5.6. So let's look at this one. Let's say we had 5x squared equals, let's do 10x. 5x squared equals 10x. And I'm going to write I don't mind writing the steps on this one to show you the kind of how to do this. This is important. So that's why I really don't mind writing the steps out. Usually I'm not a big step writer. I leave that up to you guys in your own notes. But step 1 will always be getting one side equal to 0. Okay, so 10x, I'm going to move that 10x over. So step 1, I've got to get one side equal to 0. And we like a positive x squared if that's possible. Okay, which it always will be. We'll see if we can manipulate it if not. But so step 1, get one side equal to 0. Okay, get one side equal to 0. Step 2, you're going to factor the non-zero side. Factor the non-zero side. So we got 5x squared minus 10x. I'm going to factor out a 5x, and I'm left with x minus 2 equals 0. So this was a GCF factoring, right? We had 2 terms, 5x squared and 10x. We can factor a 5, and we can also factor an x out. So once we do that, we're left with x minus 2. So we factor the non-zero side. Boom. Step 3, we're going to set. Now, this is where we use the zero factor property, right? We're going to set each factor equal to 0. And then solve. Okay, it's kind of all in one step. So set each factor. We got 5x equals 0 and x minus 2 equals 0. And then solve it out. So divide by 5. We get x equals 0. Now, it's not that it's always going to be 0. It's just these last 2 examples have had a 0 as a solution. And then we add the 2. So we get x equals 2. Boom. We have done this. 3 easy steps. Get one side equal to 0, factor the non-zero side, and I'm going to tell you that's going to wind up being the hardest part of this whole solving equation aspect, and then set each factor equal to 0 and solve. Okay? Notice when x minus 2 is the factor, x equals 2 is the solution. Kind of neat. So you can kind of jump to that conclusion there if you would like. Okay, so let's look at one that's maybe a trinomial. Okay? Let's say we had x squared minus x equals 12. Okay, I'm going to try to do a few on the same page so we don't burn through so many pages today. Okay, so first I'm going to subtract 12. I've got to get one side equal to 0. And then I'm going to factor this non-zero side. Now, look, we can do the AC method on this. Remember, AC method always works with trinomials. But also, this is the quicker one because x squared has a 1 in front. So I can automatically make the parentheses if this is factorable. And it is. -4 and 3 multiply to give me -12 and add to give me the -1. So -4 and +3. Okay, multiplies to give me -12, adds to give me the -1. Remember, there's a really -1 right there. Okay, so I've set one side equal to 0. I factor the non-zero side, and now I've got to set each one of these equal to 0. So we get x equals 4, and then x equals negative 3. Okay? X equals 4 and x equals negative 3. Okay, just butt in here, Kenley, if you've got a question. So now what about factoring when we can't do the nice, just two sets of parentheses, if we had something that you actually have to factor out. So let's look at an example. I'm stealing this one from the examples in the book. Let's say we had 2x squared plus 9x minus 5 equals 0. Now, this one already has 0 on one side of the equation, so perfect. Step 1 is done. Now I've got to factor this non-zero side. So it's got a 2 out front. I can't just put parentheses out there and do this one the way I do it. I'm going to do the AC method. So I get negative 10, and I multiply the 2 and negative 5. So I need to get a positive 9, so that would be 10 times negative 1, right? Multiplies to give me negative 10, adds to give me a positive 9. Now look, remember, when I split these apart, I like putting the negative first, so it puts the addition where it needs to be. So when I split these apart, I get 2x squared minus 1x plus, no, parentheses, 10x minus 5. Now there's an equal 0 there. Don't forget the equal 0. And then I just factor this by grouping. I can factor an x out, and I get 2x minus 1. Factor a 5 out, and I get the same thing, 2x minus 1. And then notice these are the same, so we're on the right track. So we get 2x, we factor out the 2x minus 1, right? And we're left with the x plus 5. Okay, and then I set each one of those equal to, look, we factored the non-zero side. Again, this is going to be the longest step, right? This was factoring the non-zero side. This will be the longest part in these equations, okay? Set each one of these equal to 0. Add the 1, divide the 2. I'm going to be a little lazy here. If you add the 1 over, divide the 2, you get the 1/2. And then you subtract the 5. You get the negative 5, okay? You get the negative 5. Kind of neat, okay? So that was, and again, so we've done a factoring by GCF. We've factored a trinomial where it's a little easier because the one's out front. We factored a trinomial that you have to do either the AC method, guess check method, whatever, however you like doing that. But you have to factor the trinomial in kind of a longer way. Let's look now at a special factoring, okay? So let's say we had 4x squared equals 25, something like this. 4x squared equals 25. Well, same first step as we've been doing, so minus 25. So we get 4x squared minus 25 equals 0. Well, this turns out to be a difference of squares, which the book went over in section 5.6. So it says, look, you can write this as 2x squared, and you could write 25 as 5 squared. So because we can write them as difference of squares, this factors as 2x minus 5 and 2x plus 5 equals 0. Okay? So again, move the 25 over. First step, still get one side equal to 0. And then you got to factor this non-zero side. Well, this is a special factoring from that 5.6 section. So again, if you haven't done 5.6 homework, you might not have seen that one. Even if you did it, you might have not have seen it, right away. Sometimes it takes a minute to really kind of think through. Well, then we're going to set each one of those equal to 0. What's nice, you remember these are called conjugates. And what's nice when you're solving them, you'll just get the same number with addition and subtraction, or not addition or subtraction, but plus or minus, opposite signs. Look, I add the 5 and then divide the 2, and I get 5 halves. Subtract the 5 and divide the 2, and I get negative 5 halves. Boom. Okay. Sweet. Okay. So let's look at another one, and I'm going to just see some examples in the book that look kind of different, that maybe don't start off looking the same, but they're really just solving about factoring. Let's say I had x times 5x minus 7 equals negative 2. Okay? X times 5x minus 7 equals -2. Okay. So first off, I've got to get it into like a trinomial polynomial form, right? Polynomial forms do not have parentheses. So I'm going to distribute the x to get rid of the parentheses. I get 5x squared minus 7x equals -2. Then I'm going to add the 2 over because now we've got it almost a polynomial form. I guess technically it's polynomial form, but you've got to get 0 on one side of the equation. So we're going to add that 2 over, right? So add the 2 over. So we get 5x squared minus 7x plus 2 equals 0. So now I'm going to do the AC method. So I'm going to do 5 times 2 gives me 10. Multiplies to give me 10, adds to give me a -7. Well, that's going to be -5 and -2. It's okay if you don't see that right away. Just go through all the options to get a positive 10, right? But now it's got to add up to negative. So they both have to be negative to give me that positive when you multiply and negative when you add together. Okay, now both these are negative, so it won't matter what order I put them in. So I'm going to say 5x squared minus 2x plus -2x plus 2 equals 0. And then on this first one, notice, oh, wait, I forgot the 5. Hold on, let's make this one 5. I wrote this goofy. This will be the -5x, this will be the -2. You add them together, you wind up with the -7x. On this first one, I can take out a 5x. And I'm left with x minus 1. The second one, I need to take out a -2 for it to leave me with x minus 1. Okay, and then I can factor out the x minus 1. And it leaves me with 5x minus 2. Now, and if you're sitting here going, oh my God, I don't understand that at all, you need to go back and watch the 5.5 lecture, okay? If you don't know how to factor this already into these two terms, then you need to go back and watch the 5.5 lecture, okay? It's not going to make much sense. So x minus 1 equals 0, and then x equals 1. Not just watch the lecture, but do the homework too. 5x minus 2 equals 0. Add the 2, divide the 5. And we get 2/5. Okay. Add the 2 and divide the 5, and we get 2/5. Okay. Let's keep rocking and rolling. I'm just looking at examples that look goofy. Oh yeah, let's go over a trick because we do have an equation. So if they wind up giving us fractions, what's nice is we can get rid of them really easily, okay? And this is a trick that mathematicians have used for years to get rid of fractions, and it just makes our lives so much easier. Okay, this is an example from the book. Actually, I think it's practice problem 5 if you're on page 403. Okay, so you got 2x squared plus 5 halves x equals 3. So notice the 5 halves. Notice there's a 2 on the bottom, but also notice we have an equation. So what's nice about the equation is the rule, the equation rule that we've kind of all known since we started dealing with equations is whatever you do to one side of the equation, you have to do to the other. Well, another way to think of that is almost more opportunistic, where if we do it on one side, we get to do it on the other. And therefore, we can really do some neater manipulation compared to if it was just an expression, right? If it didn't have an equation, if it didn't have the equal sign, we wouldn't be able to use this property I'm about to use, this trick, as I like to say, or hack. I guess that's the new math hack. But okay, so the way we do this, if I can open up my Sharpie, because I just put some lotion on my hands and I can't open the Sharpie. Okay, there we go. So look, you're going to look at whatever's in the denominator and you're going to multiply everything by that number. Okay, it's just every term, right? We have 3 terms going on. You're going to multiply the numerator by all 3 of those terms. So we multiply by 2 because it's a 2 down here. 2 times 2x squared plus, and put the 2 in the numerator, 2 times 5, and then 3 times 2. And what happens is these 2's cancel because it's a 2 on top and a 2 on bottom that are factors. And everything else just multiplies. So we wind up with that first term as 4x squared. The second term is going to be a 5x, right? Because the 2's cancel. And the last term is 6. And then now it turns into something that we've been doing so far, right? This is not that bad. So move the 6 over to get that one side equal to 0. And then I'm going to do the AC method again. You guys have seen it a lot now, but that's what I like. 4 times -6, that's going to be a -24. Okay, I've got to add to get 8 or 5, and I've got a -24. Is that 8 and 3, right? But it would have to be an 8 and a -3. Multiplies to give me -24, adds to give me a +5. Now I'm going to put the negative first. So I get 4x squared minus 3x plus 8x minus 6. Okay? Take the x out, and I get 4x minus 3. Take the 2 out, and I get 4x minus 3. Left with the same thing, so I get 4x minus 3 times x plus 2. So we had to do a little bit different first step, right, to get rid of the fraction. And then we can move the 6 over, and we do just the AC method again, okay? And then now for the actual solving part, we're going to set each one of those equal to 0. Add the 3, divide the 4, so you wind up with 3/4. Subtract the 2, so you wind up with -2. Kind of cool, kind of neat, kind of nifty. Okay. Okay, let's do, I'm going to do one more, and then I'll probably give you guys a few just to look at, almost to quiz yourself. Press pause and quiz yourself. Yeah. So let's say we had x cubed equals 4x. This is in the book, actually, on page 403. So the first thing we got to do is, again, get 0 on one side. So I'm going to do x cubed minus 4x equals 0. And then, look, I can do a GCF first, right? I got an x cubed and an x here. So let's take out the GCF. So if we take out the x from both terms, we're left with x squared minus 4 equals 0. Now, look, this continues to factor. This is difference of squares. So this winds up being x minus 2, x plus 2. And again, if you're like, oh my God, Mr. Shirley, you're going so fast, we need to go back and do the 5.4 homework. That's the first step. And then 5.6 homework, which is the second step. Okay, it'll make a lot more sense if you've done the homework from those sections. So now we do have 3 factors now. So I've got to set all 3 equal to 0. Okay. And we're done. Kind of neat. Now this has, notice, this has 3 solutions. And when we started back at this polynomial, it had a degree of 3. Okay. All the ones I think we've done, except for like the very first one, have had 2 solutions. And they came from polynomials that had a degree of 2. There's not a coincidence there. Okay. That is not a coincidence at all. Okay, so let me dig some examples up, kind of make a little quiz to see where you're at. And I'll choose them straight from the homework for us. Let's look. So this is on page 409. We'll just do a little quiz here. Let's do number. Okay, let me do all evens. Let's do number 10, which states n squared plus n equals 72. And then we'll do number and they really do weird stuff with these. Can't just be normal. Let's do 16, but I'm going to tell you, I'm going to give you a little trick here. C squared over 20 minus c over 4 plus 1/5 equals 0. Look, on this one, remember on the example we did, there was only one denominator. Well, you multiply each denominator by the least common multiple. So the trick for this one, I'll give you the hint. You're going to multiply each numerator by 20, okay? Because 20 is divisible by 4 and 20 is also divisible by 5. So multiply each numerator by 20 for number 16. And then steal another example. from the book. Yeah, let's do 38. You can do that when we haven't done one like it. You're going to get a different kind of answer here. N squared plus 30n plus 25 equals 0. And then okay, number 40. I'm going to give you a little bit of a trick on 40. So 40 says negative 2t cubed equals 108t minus 30t squared. On this one, I would move the negative 2 cubed over to the right to make it positive, because you want that leading degree polynomial to be positive. Okay, so if you're following along later on in the day, I want you to just pause it right here. Try all 4 of these and then hit play again, because I'm just going to go on so the video doesn't last that long. I'm going to keep rocking and rolling. Okay. Okay, so if you press pause and now you're back, let's work on these 4. So I'm using different marker. So the first one, well, we know we need to get 72 over. So we get n squared plus n minus 72 equals 0. This is that nice factoring. So we get n and n, minus 9, no, plus 9, minus 8, right? Multiplies to give me negative 72, adds to give me a positive 1. So I set each one of those equal to 0. And we have our 2 solutions. Now look, the most common issue in these is the signs, hands down, when you factor. But look, when you make that factor, just do a quick check. Does 9 times negative 8 equal the negative 72? And does it add to give me the positive 1? Okay? So let's go to 16 here. And again, I gave you the trick. Let's multiply everything by 20. Okay? And it's an equation. You have to multiply every single term by 20. Well, 20 divided by 20 cancels out. That leaves me c squared. 20 divided by 4 is going to give me 5, so that's a minus 5c. 20 divided by 5, that's going to give me a 4. And of course, 0 times anything is 0. So you wind up with actually an easy trinomial to factor. C squared minus 5c plus 4 equals 0. So you wind up with c minus 4 and c minus 1. So therefore, c minus 4 equals 0, c equals 4. C minus 1 equals 0, c equals 1. Okay? And then let's look at the other 2. So the last one, I'm going to do the AC method way. So 9 times 25, take out my calculator. 9 times 25, 9 times 25, that gives me 225. And I've got to find 2 numbers that multiply to give me 225 that add to give me 30. I have no earthly idea. So let's say divided by 5. So no, that's not going to be it. 45 times 5. Maybe it's divisible by 6. 225 divided by 6. No, it's not even. It's going to be 6. 225 divided by 9. Yeah, not 25 and 9. That's getting closer. No, it's not going to be 12. It's not going to be. It's not even. So it's not going to be divisible by an even number. 14. Sorry, 15. Oh, there it is. 15 and 15 multiplies to give me 225, adds to give me 30. So we get 9n squared, 2 positive 15s, right? 15n plus 15n plus 25 equals 0. Now look, these 2 do not equal the same thing, so we need to factor them out. N squared plus 15n, that's going to be 3n. And you get 3n plus 5. And this second one's going to be 5. Yeah, just 5. And you get 3n plus 5. Hey, that's interesting. Factor these out. You get 3n plus 5 times 3n plus 5. you get the same thing twice. So we set them equal to 0. Now you can write it twice if you want. You don't have to, because it's going to be the same answer. Subtract the 5, divide the 3, you get negative 5/3. And so really you get, what happens is you get the same exact answer twice. Okay, you get a repeated solution. Subtract the 5, so yeah, you get negative 5/3 twice. Now in your book, it's only going to give you one answer. It's going to say negative 5/3 because they're not going to repeat themselves. But realize, I know what you're thinking. You're thinking, hey, wait a minute. If it's only one solution, you told us if the degree was 2, we'd have 2 solutions. Well, you really have 2 repeated solutions. You just don't have to write it twice. Okay. Now let's look at 40 here. So again, I said, let's move the t cubed over. So we get 0 on this side, and we get 2t cubed. Let's write this in order. Minus 30t squared plus 108t. Okay, I'm going to factor GCF. I see they all have t's, but they're also all even. So I'm going to factor a 2t out. And that leaves me with t squared minus 15t plus, I think that's 54. 54 times 2 would be 108, right? Yeah. So now I've got this nice trinomial. Well, again, this is the easy factoring because t squared by itself. I think it's t minus 9, t minus 6, right? Multiplies to give me 54, adds to give me 15. And I set each one of these factors equal to 0. T equals 0. T equals 9. Oh, wait, that's 6. So t equals 8. So we get 3 solutions. And again, we got 3 solutions because we have a degree of 3 to start with. Okay. And that's why the section I titled it Solving Polynomial Functions. I think that's how they said solving equations by factoring and solving problems, and not just solving trinomials, because even though the majority of the questions in this section contain trinomials, there are some that are polynomials. Okay. So for homework, we're really done with this section. Okay. It's not a long section, and it's really just the filler of it is just being able to factor. Okay. So the homework is going to be, so this starts on page 408, I believe. No, 409. Page 409 in your book, section 5.7. Okay. I want you to start on problem 1 through 65. And I'll tell you, even if you do every other odd, you'd probably be fine. If you do every other odd and then you're still struggling, then do every odd. Okay. You'll know right away if you need to do all the odds or just every other odd. Okay. So do every other odd, and then if you start struggling, just do every odd, and you should be okay. Okay. Great. So again, now we've got a test coming up. Just like before, I'll create it and I'll send you the information. It'll be the same directions as the last 2 tests. I can't believe we're on test 3 already. That's crazy. If you guys have any questions, please let me know.